right, I think we'll get started. Good morning, or good day, good evening, depending upon where you're dialing in from around the world. My name is Tom Tansey. I'm with the Sunspec Alliance, and I'll be your host today. I want to welcome you to the Sunspec Alliance webinar series, this one featuring the Sunspec Modbus technology and Nuvation Energy. Okay, and we're going to have to, and as we get started here, I'm going to ask everyone in the audience to go along with some house rules. One is that if you intend to speak, please do speak up anytime. This is an open mic presentation. This is GoToMeeting and not GoToWebinar, so that means that anybody can speak up at any time. With that said, if you do not intend to have your voice heard, if you'd be so kind as to mute yourself, I'd sure appreciate that as well. Also, as we get started, I guess I'm covering the housekeeping first, but I want to make sure that everybody understands that you will be receiving a follow-up afterwards, and you'll be getting a recording of this presentation. And so that means that you'll have the ability to access materials afterwards and follow up on any particular topics that you have of interest. As I introduce this webinar series, I want to again thank Nuvation Energy for helping us kick this off. This is an important initiative for Sunspec to broaden the understanding of core technologies as they pertain to DER. And so I want to just let you know that the Sunspec Modbus standard itself has been specified in the IEEE 1547 standard. And for those of you that track such things, this is the US national standard for DER, the Canadian standard as well. It was established in the Energy Act of 2005 in the United States as the US law. Now, within the context of regulation for DER, any federal law, of course, has to trickle down to the states, and the states are now actively engaged in adopting this important standard. California and Hawaii led the way, and at present we have about 35 states that are all planning to incorporate and adopt IEEE 1547, the latest version 2018, no later than the first quarter of 2023. So that puts it somewhere in the neighborhood of 12 to 18 months out between now and the time when all DERs must support a standard communication interface. And Sunspec Modbus and the information models being based upon the Modbus standard is the most convenient standard of the defined standards to implement, and we have on good account that it will be the preferred interface for distributed energy resources going forward. And so back to the point of this webinar series is that 2022 is a big year for the industry. It's one in which industry will be required to understand this technology and the other technologies in IEEE 1547 and then implement the technology in products and services. And so in 2022, you can expect to hear from us every month with a new installment to help you better understand, implement, and then ultimately deploy these Sunspec Modbus networks for DER in the field. And so, again, we're very pleased to have Nuvation kick off the series for us and get us started. They're going to give a great explanation of how the Sunspec Modbus models are used in SecondLife applications for energy storage. About the Alliance, we got started in 2009 as a trade alliance to promote and develop this idea of standard information interfaces for DER. And I'm quite pleased to announce that our progress has been steady. And now at this point, we are recognized as a standard in many different countries, the US and Canada, as well as Poland and Denmark. Also, we understand that Belgium has recently adopted the standard, and we have at least partial integration for Sunspec Modbus in Germany as well. We have over 140 members today. The membership is spread out across the globe, about a third in the US, a third in Europe, and third in Greater Europe, again, Greater Asia, excuse me. The types of companies involved range from Fortune 100 to startups, but I would say that we have quite a number of large established companies in the Alliance. We have more than 1,000 adopter and partner organizations that have implemented our standards, besides just the membership itself. We have programs for certification for Sunspec Modbus, of course, for the other 1540 standards as well, for IEEE 2030.5. And we have a cybersecurity initiative that we've been running with Sandia National Labs pertaining to DER. That's now starting, actually its 5th year. And so this has been a very successful program, again, with over 1,000 participants involved in it, where we are establishing best practices that ultimately can be applied for standards for cybersecurity in DER, which is really a critical issue for our industry going forward. We have a great set of board members. We're proud of all of our members, but there's the logos of some of the leaders that we have involved in the organization. Our intention in all cases is to publish information that can be adopted royalty-free. So this is a key part of the Alliance, is to eliminate these barriers and friction for adoption. And so we're proud of being able to do that. This meeting, like all meeting, is governed by the Sunspec antitrust and intellectual property provisions of our member agreement. And you can find that agreement at the link shown. Sunspec strictly prohibits market participants and their employees who participate in Sunspec activities from using their participation as a means for engaging in practices that violate antitrust laws. Confidential or proprietary information should not be discussed in open session, so please contact me or other Sunspec people on this call if you have any questions. So thank you for allowing me to get through that. And again, you will get a copy of the recording, and so that's a good reminder. If you do not agree to have your voice potentially recorded or your presence noted, now would be a good time to leave, but I certainly hope that you won't, because we have a great program coming up. All right, and with that, I would like to pass the baton to my colleague, Steve Miller, who will be leading us through the presentation today. So, Steve, I am passing control to you now, and there you go. You should have it.
Yeah. Thank you, Thomas. Thanks. Great. Yeah. And sorry, while just do a couple shifts here. Thanks very much for everyone for welcome, and thank you for attending this webinar today. My hope is that I'll teach you about secondary energy storage and some of the design and architecture trade-offs that that Nuvation has learned as we've deployed these systems out in the field. So myself, my name is Steve Miller. I'm a principal software engineer at Nuvation, and I am the manager for the BMS firmware and I have 26 years of experience developing firmware, and I've worked in many fields from energy storage to aerospace to communications. And I've been over 10 years working at Nuvation. So the agenda today is going to cover about 5 areas. The first area is going to be first talking about Nuvation, who we are and what we do. The second is going to be focused on the SecondLife energy industry. We're going to talk more about that industry and the reuse of SecondLife batteries. Then we'll get into an area for for the SecondLife stack construction, and we'll be discussing different ways in which you can design and construct SecondLife stacks. And from there, we'll lead into talking about kind of control architecture and communication. And mainly, this is where we'll focus and discuss more about the Sunspec models that Thomas was mentioning. And lastly, there'll be a Q&A session at the end. So to begin with, Nuvation Energy, what we do is we provide battery management systems and energy engineering services to organizations for designing and building energy storage systems. And it really begins off the basis of our battery management system. It's a UL recognized battery management system that can be applied to any battery system. I'll go on to that later. But on top of that, we can provide energy storage solutions. We actually have controllers and to help manage your DUR assets. And we have kind of a worldwide installations. We have over 150 installations of our product from in front of the meter and behind the meter, and as well as in aircraft and naval vessels. To give you a kind of example, here's a map of the world that shows all of our installations. So we have incredible kind of breadth in our deployment around the world. So we're returning back a bit to Nuvation. Nuvation itself. Nuvation was started in 1997. It's focused on providing engineering design services on a contract basis. And we've solved many problems for clients over that time, and it's gone from ocean floors to space, and or from one-off solutions to high volume production. As well, we cover the consumer, medical, and military sort of areas. So we've kind of done the whole gamut, and it's included over 1,000 projects in that time. And about 2008. Nuvation Energy was created, and we had the sole focus of creating a highly configurable BMS, and that has been our focus and our core for our system. So, getting onto that, that point there, the BMS is our core to our product level. As I mentioned earlier, it's UL recognized for certification for UL 1973 and 9540. It's very highly flexible and can be refigured to a whole host of chemistries that you see below, and it allows linkages to higher level software systems, and that don't even have to understand the battery in which they're communicating to. So on top of that, we have what called our stack switchgear, and it couples in all the components like fuses and contactors and safety elements. And so it essentially provides all those safety elements. You connect in your battery and your DC bus to this, and you just provide. It's kind of a one-stop box that provides a whole host of functions. I didn't mention before, but our BMS does go up to 1,200 volts, and in this stack switchgear, it goes up to 350 amps, and is a 4U rack-mounted unit. On top of that, Nuvation Energy has a product called the Battery Control Panel, and it enables the aggregation of multiple stacks into a kind of a unified single point, which controllers can then interact with. So, and at this point, the product can support 36 stacks. And so it avoids the controllers going around and pulling all 36 stacks. They can just come to the one central point for their communication needs. And as well, Nuvation also offers end controller for energy management systems. And again, it supports both front and behind the meter installations. And it manages your DUR resources and provides a mechanism for performing demand charge management. And we'll see a lot more of these kind of diagrams through the presentation as we go ahead. And lastly, sort of all those sort of components combined really provide Nuvation Energy a footage for doing integrated battery control and energy management system. So, and that's kind of playing to our strengths. It all builds from a solid BMS and building up from there. And these are all services that Nuvation is very comfortable with and have deployed throughout all those installations. So I got to apologize a bit. I'm putting up a pretty complex diagram here. This is more for discussion orientation, and we'll see more of these diagrams later. So pardon me if I don't explain it now, but first part of our discussion is in this green box where we're going to be talking about the design for SecondLife stacks. And then later on in that continuing discussion, we'll talk to its communication to its local controller here in this larger green box. And then as we get into the last half of the presentation, we're going to talk about the whole system and its control. So you'll see these slides appear when I'm shifting around, just to give you a reminder of the scope of the presentation. So with that, we're going into the SecondLife energy industry, and I'm going to give a lot of background on the industry and what we're trying to achieve through SecondLife battery usage. So the first part of my presentation has to say, what is a SecondLife battery? And it's, by its definition, it's a battery from its end of life usage from its initial application. So, and for the most source of batteries, it's going to come from the automotive industry, because our EVs are now starting to get more mainstreamed. And whenever their battery packs come to the end of warranty and are replaced, we're talking about using those packs in particular. And so that's what this picture shows in this diagram. That's a battery pack from a Nissan Leaf car. And just for definitions point of view, I'm going to be referring to these battery units as SecondLife packs, just like they are in this diagram. And so the next question might ask is, well, how much energy are we talking about here? And this is just a sample of it, and typically it seems 8 years is a very standard, and 100,000 miles is a standard warranty period. And the guarantees that these manufacturers are providing are roughly between 60 to 75% of the capacity, their nameplate capacity. And if you work that out on the right side there, that's the amount of capacity that you can expect from your SecondLife batteries in usage. So then, next question is how many batteries are we talking about here? And I did take this kind of reference from the McKinsey & Company report there, where they talked about the growth of EV batteries throughout the world here. And we are talking about gigawatts per year, which is a phenomenal amount of energy. Just thinking about that, that's what's on our roads today, or very soon, within that eight-year cycle. And of course, what it also shows is that it's dispersed amongst many geographic regions. So this is not kind of a North America thing. It's around the world in the major sections, major economic sections. So to kind of fill this discussion out, I want to kind of show this diagram to show, what does it mean to use the batteries afterwards and what happens after that. And this shows your typical 3 R's of recycling. Not much in reduction, but really the reuse and the recycling of the batteries. And once that battery comes out of the car, it often goes to a battery refurbishing company. And they'll take the battery, they'll assess it, try to categorize the battery, and then those batteries are brought into the bottom right corner for SecondLife applications. Once they have had a long time of use through stationary energy storage, they get put back into the recycling for extraction, and again, so that's the kind of cycle here. And our discussion is really focusing on this bottom right corner today. So with that, we'll go into kind of discussing SecondLife stack designs. And
excuse me,
sure.
I have sort of a very fundamental question, and that is that if I'm going to buy a battery for SecondLife, I think that what I really care about is the expected life and not how much capacity it has. And so it's easy to measure capacity, but how are you going to tell me what its expected life is?
That is a measurement that is coupled with a metric called state of health, and it is not a metric that is standardized across the industry. And Nuvation has a lot of research and continuing research into the state of health. But if you're looking at establishing what the lifetime of battery, it would be reflected in a state of health.
Right, but state of health isn't a property of just the battery. It's a property of its history too. Do you imagine having a lot of history for these batteries?
And the history could be, might be coupled with the battery pack. If the the measurement of the capacity, it really depends on the battery pack. I can't really, you'd have to go case by case. It's something that, Nuvation as a product in our BMS, we do monitor state of health, but of course we'd have to initialize it at some point. That's a good question, but it's the short answer is it is going to be a metric of the state of health of the battery, and that'll fluctuate from manufacturer to manufacturer. So getting onto the SecondLife stack design, there's two main approaches. One is to actually use the whole SecondLife packs unaltered, and the other is to really disassemble the packs and to rebuild a stack for a particular stationary application. And so I'm going to be discussing both of these approaches, and in each approach, I'm going to be evaluating the pros and cons of the approach. We're talking about the reuse of the pack components, and we'll be talking about the stack communication to its local controller. So first, I'm going to focus on the whole SecondLife packs, and here the photos I'm showing here are from a deployment with EcoStore and Nuvation Energy, and this is an ESS that was deployed in Norway at a local school, and it uses Nissan Leaf packs. You can see here on the right here, there's a bay door open. It's showing the packs there, and this is one of our deployments that shows SecondLife whole packs that have been deployed. And when we look at the pros for this approach, it really comes down to like a minimal work on assembly. You're basically taking a product that is, you're just reusing the product as is, and you're able to reuse 100% reuse of everything on that battery pack. Any of the automotive certifications may be still maintained. You'll have to work with the manufacturer on that, but they have been certified to an automotive standard. So there is a potential of extending that certification through its reuse as a whole pack. And the last 2 points there sort of point out the mechanical strength and the environmental. That comes from the automotive design. You're dealing with something that is relatively strong and is designed for different temperature environments. But of course, it lacks the air cooling that you used to have from the car, and you'll have to design that in to your ESS. The cons list for this approach is fairly long, and really when it comes down to is the worst cell in each of those packs will determine the pack performance. Now your refurbisher can gauge that, and they may be able to repair damaged cells, but you will be limited to whatever the current damage of the stack is. There's also limited access to the proprietary design and operation of these packs. So that is something that'll help you work with the pack designer, the automotive industry, to get the details on it. And it takes time, but it can be achieved. The pack design, obviously, some can change over time. In fact, you can get different versions of the packs, and you need to plan for that. There could be different electrical connections that you have to maintain, different software in the controllers that might be a little bit different. These are factors you have to include. The form factor for it's really meant of the battery. It's meant for the bottom of a car. It's not designed for an ESS, but it can certainly be used that way, like just we've seen with EcoStore. These are also tend to be very large packs. They're weight and volume inefficient. They're heavy and they're very large, often requiring heavy lift capabilities to move them around. And parts availability. You're talking about automotive cables and connectors, and even in our time of supply shortages, these connectors could even be that much harder to get hold of. And on the third last item there's the design for continuous high C now of the packs. Now cars can deliver high current, that's what they're known for, but to deliver that continuously for many minutes or hours for that part, your pack may not be designed for that. So you really have to look at the application of what you're trying to do with these SecondLife stacks. And also all the packs are in the automotive industry, they're automotive communications, namely CAN. And as I mentioned earlier, the cells may not be designed for stationary applications. You really have to look at your application you're designing for and whether it can take in, whether it is a good match for the SecondLife pack. So just to reiterate, a couple important design factors when you're looking at these packs is really you have to design for maintainability. You have to be able to swap these packs out easily, and if there are any concerns with them. You also have to design for diagnostics and prediction replacement, and that lends to that state of health estimation. You do need to have some metrics that can identify when cells can do, and Nuvation continues to invest in a lot of algorithms and predictions for that. But because we're using the pack, we're separated from that, and you have to rely on the manufacturer's diagnostics themselves. From a reuse point of view for the SecondLife packs, it's, like I said, it's 100% reuse. You're pretty much using every unit that's in the pack. And with that reuse, the pro of that is that you get continuity with manufacturer support, that they will often be extending collaboration to work with that pack. Now the cons for the reuse are that it's difficult to access quality parts in an unopened. It's difficult to assess the contactors or the quality of the parts within the pack. And likewise, you also have to abide by the manufacturer's pack operation. So if they're controllers, it's pretty standard. It's a standard operation that a battery controller will disconnect the battery to establish its SOC the night when the car is inactive. That's not something you want. You do have to plan for that because that's what it's the controller is expecting. And lastly, you do have to convert the CAN interface into something more industrial, standard industrial protocol like Modbus TCP. So as an example for communications here for these packs, what it kind of implies is that Nuvation has designed this device, we call it the SecondLife pack controller, and it provides both the communication and I/O or electrical interfaces in particular, so that the pack thinks it's in the car. It actually believes it is, and we can communicate with this SecondLife pack controller over Ethernet to Modbus to a higher level controller like our end controllers. And this is kind of a typical deployment that you would see in a SecondLife pack system. And it could be several different PCSs to packs. Likewise, it's also sort of beneficial to get the power conversion system for these stacks up to a higher voltage so that the power conversion system is more efficient. And it would kind of mean putting these packs in series with each other, like this diagram it shows here. But there are some concerns when you do that, like achieving these higher stack voltages, you know, will mean you're open to higher short circuit currents. If you short the stack under the high voltage is a higher short currents. The insulation of the packs may not be sufficient. You have to work with the manufacturer to understand what their insulation capabilities are for their packs and whether you're capable of doing this series connections of them. And likewise, the communication reference challenges. CAN is a differential signal, but you do have to match that to the pack. And when you get these packs operating at different voltages, you do have to manage that. And lastly, you also have to look at balancing between the packs. So you have to look at being able to supply balancing currents between the packs if they ever became unbalanced. These are important kind of design decisions that have to get built into your deployment. So that ends kind of the first type of stacks. The second type is to really look at refurbished cells and building them up and establishing your own stacks. And the photos here showed sort of two such of these stacks. One on the left here is from a company called Spears New Technologies. They are a refurbisher, and Nuvation's worked with them to build a stack here that is used for charging of automobiles. And like the stack on the right there, that's a stack that was built by Nuvation in 2016. We affectionately call her Bessie, and Bessie is used for load shifting, and it too provides charging for employees' EVs at our Sunnyvale office. So looking at the pros of this approach, you get a lot more control over your stack. Like you can actually start to, first of all, you can take only the quality cells for capacity, and that's another way you can get a higher life on your stack, is going to this level. Likewise, you can design for stationary form factors. The packs, like I mentioned before, you do have to, if you're looking for UL 1973, there are considerations made in how for that certifications. And you can also, notably, you can design your stack for the PCS. So those challenges of putting those packs in series, you can design that into your stack. And lastly, you could also upgrade the BMS and start in one like provided by Nuvation. The cons to this approach, of course, are there's a lot more NRE and effort to design and construct these stacks. And of course, you're going to lose any of the pack certifications. Now, if you can maintain the information on the cells, that's going to be important for any post certification you do. But from there, you can design your packs to meet stationary certifications with that kind of knowledge. But again, also you do have to look at your application of the cells, and these pack cells may not be designed for all they're definitely not designed for all stationary storage applications. So you do have to take that in consideration. And likewise, as soon as you open the pack, you lose any support from the manufacturer. They're not going to speak to you or help you. They're not motivated to help you in that scenario. So some important design factors, it really all comes down to design. For these refurbished stacks, you have the capabilities of designing your stack for your needs and your capacity of your stack. And you also can use elements which are safety rated for stationary storage, which will operate at higher, which can operate at higher voltages. So from a stack communication point of view, Nuvation provides what we refer to as what I mentioned earlier as the stack switchgear. And basically you're able to take that refurbished stack and connect it to our stack switchgear, and it natively communicates over Modbus and using the Sunspec models. And from a reuse perspective, it's a little bit less. Really what you're getting from the refurbishers, you're really just getting the cells and maybe the interconnects between the cells, reusing those. It may be possible to reuse the contactors and fuses. It all depends on your application that you're using for the stack. The refurbisher will recycle the mechanical enclosure and all the other electronics that go with the pack. So really the reuse from a secondary is limited to really just to the cells and the interconnects. And there's not much of an advantage over that. Like I mentioned before, you do lose manufacturer support when you start opening up these packs, or you have limited support. So at this point in the discussion, I do want to I'm going to be switching back to we've been talking about this area down here as a reminder, and now I'm going to switch over to kind of the control aspects, which is going to take a larger breadth, and I'll be explaining this diagram in more depth.
Hey Steve, this is Tom.
Sure.
I just want to do a quick time check. I know I took a little bit more time than we thought at the beginning. It's now 9:38. We've been having a very active dialogue in the chat and answering a lot of questions, so that's been great. So for the audience, please keep the questions coming, and for you, please feel free to go over a bit
Okay.
as well. Yeah. Okay.
Great. Thank you, Thomas. So we're going to move into the control architecture here. And one of the first kind of questions, as Thomas was mentioning earlier, there is the use of the IEEE 1547 and specification. It's really a mandatory communication interface. If you're going to connect to the grid, you have to implement that standard. And this diagram here is the red rectangle you have to kind of focus in. So there's a lot of network and communication there, but really the specification is focused on that interaction between an individual DIR, or more likely a system of DIRs that are below with the control system. And this standard has been around for about 20 years, and it has been evolving as Thomas was mentioning earlier. It's, back in 2003 when it came out, it was kind of loose in what the requirements were. There were not that many takers in connecting back to the grid, but over the years, you can see it got more and more strict to you must provide these high functioning services using this standard whenever you're deploying to the grid. So from there, what I want to kind of come back to this diagram I've been showing before and really discuss what it means. It means that you should have a kind of a layered approach to your control. If you're talking IEEE 1547, it's mostly in this area at the top layer here, just before, as you're connecting to the grid. That's the implementation point for the standard. And what's better is to actually, what I'm suggesting, it's better to manage having another layer of control through energy management that is controlling all your individual DIRs below that. And that's why I have this kind of hierarchy of control. And so when you look at a system as a whole, like here where there's multiple controllers, there's also multiple protocols going on. Now, at the top level there, the DNP3, that is the suggested protocol for IEEE 1547. And the Sunspec models, as we've been discussing before, they work on industrial protocols, like namely Modbus TCP or RTU. And likewise, there's also support for JSON interactions as well via HTTP. So there's multiple protocols, and that's primarily what we're going to be talking about, is that communication, the models going forward. And so the next slide is really, I want to take this back a bit and simplify the control hierarchy here and say, you know, this is the essence of what we're talking about from a control perspective. And from a controls perspective, you want to talk about the data that's moving between these layers and how it's managed. So if you look at the top layer, really we're talking about grid status, grid control, any kind of DIR requests for the lower systems. If you go down into the energy management layer, it's more about DIR status. What is the status of the DIR? Creating some power commands for the DIR and connecting and disconnecting the DIR as needed. And then to the bottom levels, at the meter, PCS, and the BMS, they each have their own sets of data: the power measurement for the meters, the power status and command for the PCS, and for the BMS, it's really the current limits, SOC connection, but you know, other things like current and voltage are also kind of available. And this is kind of the models that we want to use have to reflect this kind of structure. And when you look at that, what I'm going to suggest is there's a combination of both MESA and Sunspec data models that allow this kind of same architecture. So on the top half, it's really using what's referred to as the MESA DIR models, and they specify the DNP3 protocol. At the energy management system layer and below, we're talking more about the Sunspec energy models, and there are models for all these different types. And I'm going to step back and just, for reference purposes, give you the exact kind of URLs and the naming here. So MESA stands for Modular Energy System Architecture. It's promoting the DIR management and communication over DNP3. Sunspec energy models standards, that's from Sunspec, and it supports all these different protocols for Modbus RTU and TCP, as well as some JSON interactions. And from a modeling perspective, there's a variety of different categories of models. They're given numbers. So the 700 series, and all this information is on the Sunspec website. I won't go into the details of the models because they're highly available on their websites to look at them. But there's the 700 series, which is the DIR model itself. The 800 series, which is Nuvation's very familiar with, that's the battery storage models. And likewise, there's the inverter models and the meter models as well. So I want to go into a little bit more about what these models mean and how they're used. And really, these models, there's a structure within Sunspec that allows you to combine the models. Defines a start and the end to the models. So it starts at the common model and ends at the end model. There's no restrictions that you use Sunspec only. You can find Modbus points outside of this model range. You can scan a Modbus map and find models by their definition. So you don't, that standard is well set up. And another thing is that the models can also contain multiple instances of data. So, and I'll give an example of this kind of on the next slide here, pertaining to kind of the products that Nuvation has. So on our stack switchgear, it's providing stack level information. So we can arrange the models like this. The 802 is like the base model. 803 is your pack level model, and 804 and 805, or 805 is the module level model and describes all the cells data. So there's a lot of detail in that setup, but you can equally turn around and you can say, I'm going to aggregate a different set of models for my battery control panel. And you can see here the 803 model is larger because it has what are called repeated blocks. It has the repeated blocks for every stack. And so it gives a single view for all the stacks down through that model. And sorry, sort of to follow on with that, this use of the data models allows for some abstraction. So you can start, if you look at the bottom stacks through here, you can use different types of stacks, and they can be represented through these Sunspec models up, and you can get a different abstraction. So it makes augmentations of sites easier to manage and work with. And that is sort of my final point that I'd like to wrap up this discussion on.
All right, excellent, Steve. Thank you so much. That was an excellent presentation, to say the least. Very, very instructional. Now, we have been handling questions in the chat box as time has gone on, but I've selected a few questions to ask you. And let's start here. First of all, with regard to SecondLife battery packs, can you mix and match battery packs from different manufacturers in the system? And if so, are there advantages or disadvantages to doing so?
We haven't done that in Nuvation, and I think within a stack it might be difficult to do, looking at the interactions, but to take different stacks of manufacturers, certainly possible to manage that, as long as they're managed together with the same PCS in mind.
Yeah,
or possibly
Mike
they're
Ward
already
online as well here.
Sorry.
And Nuvation's done systems where exactly what Steve was saying, in an individual stack, you want to typically keep that to be cells of a similar state of health and from the same manufacturer. But certainly stack to stack, Nuvation's products allow you to mix and match different battery manufacturers, different state of health, different stack voltages, depending on what's needed for a system. Particularly if you use string inverters, then you can have good system flexibility. So we've done energy storage systems that actually combine, new cells with SecondLife cells, and that gives you kind of the performance cost trade-offs and the ability to dial those up and down system to system.
Very good. Next question is, you mentioned that your system supports peak voltage of 1200. Do you have plans for a 1500 volt system?
We do. Our next generation battery management system goes to 1500 volts.
All right, excellent. Next question is, are there ideal applications for SecondLife batteries in terms of the stationary applications, that is? Are there particular use cases that are well matched to SecondLife?
Yeah, good question. What we've seen is that in SecondLife systems, systems that don't have as strong requirements around volume or weight, because if it's done at a pack level, it takes a bit more space and weight because of the automotive packaging. So those are better match. Applications that are perhaps backup power rather than daily cycling can be a better match, because going into a SecondLife application, you've already consumed some of the cycle life of the battery. And so if you use it for a backup application, those are much lower cycle life, and so it can last much longer. Also applications that are, for example, renewables integration, so that you're operating at half C, quarter C, even less, are a good match. High power applications consume a battery more quickly. And so since it's already in SecondLife, generally we put these into applications that are on the lower power side.
All right, sounds good. A couple of more technical questions. Within your system, can you isolate one pack if there's a problem?
Yeah, so in the battery topology where you've got string inverters and individual stacks, you can definitely isolate individual stacks. So for example, that 40-pack system that we had in Norway, we can individually take stacks on and offline in order to operate the system. So if you have one stack go bad, you still continue to run with 39 packs. In the other topology we sketched out, where you're trying to get to a higher voltage and you put 2 packs in a series in a single stack, then if one of those goes bad, you'd end up taking both stacks, both of the packs offline. So you can basically do it at a granularity of the string.
Okay. There was a related question about how is internal cell balancing handled by the switchgear?
Yeah, I threw out an answer to that in the chat. The stack switchgear level makes the decisions on how to do balancing. So it takes in information on the cell voltages as well as system level information around stack current, temperature, and so forth. And with that, it decides what balancing algorithm to use and which cells require balancing. It then distributes those commands to the module level BMS, which in the Nuvation hierarchy is called the cell interface. It then implements cell balancing at a cell level.
Excellent. Okay, well, switching gears from technical to financial, Alex Marlowe asked, what is the break-even in terms of dollar per kilowatt hour cost of a SecondLife system to be market competitive? So what's the target cost that you're aiming for with the SecondLife system in order to be competitive?
So typically SecondLife systems do need to come in at a lower price point in order to compete against new systems because you've already consumed some of the life. So we're typically seeing SecondLife systems being in the range of 20 to 30% cheaper than new batteries. And I think the price point of SecondLife batteries will always track to something below new batteries. So as new batteries continue to come down in price, as we all predict and expect, SecondLife batteries will follow that curve. Fundamentally, SecondLife batteries are a negative asset, meaning that they cost money to either store them or recycle them. And so I think they'll always find a home in SecondLife applications. And basically the market will determine the price of that.
Very good. Back to on the technical front, what are the certifications, safety and otherwise, that would be required for SecondLife systems?
SecondLife systems generally fall into the same certifications required in the field as First Life systems. So typically that's UL 1973 at the stack level and UL 9540 at the system level.
All right. Okay, very good. And in general, we've been talking about larger systems here that would be used for a field-based solar generator and the like. So do you do anything, or do you have products that fit more within the C&I framework or residential framework? Does that make sense for SecondLife?
Sure. Actually, a number of the SecondLife systems we've done have been in C&I type systems. So for example, with Nuvation's high voltage BMS, it's a really good match. Typically those are done with systems that are done at the module level rather than the full pack level. But then you combine it with our cell interfaces and stack switchgear and can deploy C&I SecondLife systems. We've done several of those. We got also down to the residential system. So we've done projects and applications where we also have a low voltage BMS that goes up to 60 volts. And then you can put, for example, up to 7 of those Nissan Leaf modules in a stack, 14 cells, and operate that below 60 volts, which is convenient as it falls below 60 volts. It's easier safety regulations.
Well, very good. Well, thank you so much for all the information. It's been a wonderful dialogue that we've had here today. Looks like we have maybe one more question coming in.
I see one here from PE. He says, are you assuming whole packs are sourced directly from manufacturers, or packs removed as a result of accidents or warranty claims? So there are companies that process that. So we have a really good partnership with Spirit New Technology, and that's what they do, is they receive packs that have been removed because of accidents or warranty claims. And then they can either process those at a pack level or disassemble them and make those available at a module level.
Excellent. All right. Well, with that, again, I want to thank you, Steve, for your wonderful presentation, and Michael for your commentary at the end to answer any of these questions. And thank you to the audience here for allowing us to take some of your time today, and we really appreciate it. Now, there's more to learn here, of course, and Sunspec will be offering yet another webinar tomorrow morning where we will be featuring a team from Simani. This is a cybersecurity for manufacturing U.S. national initiative. It's related, obviously, but from the standpoint of integrating cybersecurity directly into the manufacturing process. So that's tomorrow at 9 a.m. Pacific. If you want to tune in there, there's always more opportunities to learn, and you can learn about all the other events that we'll have coming up in 2022 by going to the link shown at sunspec.org/events. And again, thank you to all of our participants today. You will be receiving a follow-up message to us to thank you once again, and that will include a link to this webinar, so you'll be able to replay it and extract information from the slides. With that, we will be wrapping up for today, and so have a good day and happy holidays to all. So long.